Hi, I'm Randy with Roanoke Landscapes, and I was hoping to talk about segmental retaining walls here for a little bit this morning. We have been in constructing, building walls of this type for almost 20 years. They've been out for some longer than that, 30 years probably. Different manufacturers, different building or making different types of block. The one we have here on this job today is Allen block. It's a cord block, meaning there's a hole in it that gets filled with gravel eventually. They are engineered walls, engineered block. The manufacturer does the engineering on the block, and of course it's depends on the material that it's made from, how it's constructed. The engineers determine what it will hold back and what extra support, what extra elements need to be incorporated to make the wall do what it's designed to do. The engineering part, there's supplemental engineering once you get to a certain height. There's actual extra engineering by a professional engineer needed to design the wall. Usually that's somewhere north of 4 feet. Can vary a little bit depending on the surcharge, meaning the what's going on behind the wall. Is there a hillside, a slope? Is there maybe going to be a parking lot right up next behind the wall, possibly a swimming pool? All that has to be considered prior to designing the wall. This project that we're on today, the wall in places, just where I'm standing here, is upwards of between 8 and 9 feet tall. Tapers on the ends where it's not going to be that tall, but we did have to hire a certified or a professional engineer to design this wall. This is the plans he sent us here. Of course, he has his techniques for doing the design, but it's pretty clear on what we need to do. Then you approach your local government, county, city, or whatever, and usually they're requiring a permit to construct that wall. Especially in our area here in Roanoke, anything above 3 feet requires a permit. Anything above 6 feet requires supplemental design, meaning the PE to design the wall and what goes behind it. So we did have to have it designed, and there's supplemental reinforcement here. The area behind the wall they call reinforced soil. I'm standing on a product they call GeoGrid. It's designed to go in between the courses of the block and extend into the reinforced area, the area behind the block. And then when you backfill this area and compact your backfill, it works kind of like a Chinese handcuff. So once you backfill it, it's pulling back on your wall. That, along with gravity and friction and mechanical block on the block, that's what provides the support for the wall, and not hopefully doesn't fall over. The higher the wall, the farther you need to go into the ground. there is a factor called global stability. So in the past, they figured out that these walls sometimes fail where the weight behind them will, obviously the deeper you go, the more that is. So it will push out the bottom of the wall if that bottom of that wall isn't far enough in the ground. Of course, the higher the wall, the farther you got to go in the ground. So as a rule of thumb, you need to go 1 inch per foot, per vertical foot into the ground. We try to do that, or sometimes 1 inch per course. These blocks are 8 inches tall, so somewhere in that range, going down below grade in front of the wall has to be of sufficient support that you can't build on mud. It's not gonna resist that push out at the bottom. So in this case, we went down 2 courses, 16 inches. And again, it's going to be in the neighborhood of 9 feet tall right here where I'm standing. So just to finish with the block, this alum block is cored. So all these holes in the block that you can see or will see are filled with stone. We use number 57 limestone. Normally that's readily available in our area, and economically it's hard to do much better than that. So that's what goes in the block. The first foot behind the block is a critical zone. That is all stone, clean stone. At the bottom of that is a corrugated pipe. You see, I think maybe you can see that. That's the start of it, where we already have built and covered up here. This continues the length of the wall. It's again corrugated, of course, and perforated, so it handles the water that would go down through that wall and mitigate that issue by, this will be vented through the wall in several places, so hydrostatic pressure is relieved by way of that. Of course, the water goes down through that rock that we have readily through that rock right behind the wall, and then vented out in front. The rest of the backfill can be native soil if it's of sufficient integrity to actually have resistance to it. That is, I mentioned mud. You can't backfill with mud. If it's, we have in places around here this yellow clay that's just really junk, and you can't really compact it. It is not recommended for the backfill. Usually if you have an engineer involved and he realizes that's what you have, then you have to ship that out and bring in a more suitable backfill. And again, it's usually stone. The backfill is also relevant to the height of the wall, the amount of backfill, the area, the length of the backfill. So again, this wall was somewhere around 9 feet. The engineer called for about a 6-foot length of geogrid placed in the wall, in the block, between courses, and stretches back into that backfill. And these are multiple courses. They're about every second course in an 8-inch block, so every 16 inches there's another course of this geogrid. If the wall, like our wall, is going to taper down on this end and tapers up on the far end there, so we're only 3 or 4 block high on this end, so the geogrid won't be used up there. Somewhere in this transition area, when we get where the wall is less than 5 foot tall, give or take, the geogrid's not necessary. The back to the backfill, we put the backfill in somewhere 6 to 8 inch lifts, and then we compact it. This is some of the equipment we use constructing these walls, and primarily it's compaction equipment. This is a plate compactor, vibratory plate compactor. That's used in the footing. The footing is the stone again that you see here. So there's 6 inches of stone in the footing before you ever start the wall, and we wrap the trench that we dig to put that to put the wall in with geotextile fabric. That's to help keep mud, clay, whatever from migrating into that stone base. That's used to compact it. This compact the stone. It doesn't do very well. Plate compactor doesn't do very well on just dirt. We use this among other tools to compact the backfill in the way of dirt, or maybe there's a little rock in it. This is a jumping jack, or some people call it a rammer. We use this extensively in this backfill. Again, we're compacting. Every time we put a lift of backfill material in there, we're using this to tamp that down. We have a couple pieces of equipment here. The track loader, mini track loader, which we use to do this excavation. This project was just a hillside, a slope right here out from where I'm standing, another 12, 14 feet, I guess. And we have a property line involved here, so we had to stay behind that property line. There was an old wood retaining wall in this area that was put up when the home was built, and they were over the property line several feet, so that had to go away. We cleared that out and reestablished the property line. That's the stake you see up there with the pink flag on it. That's it. So we're trying to stay behind that property line. You always start with these walls at the low end. It's really hard to build down, so we're always trying to build up. So right over here in this corner was the low area, so everything goes up. There's another wall that tees off of this to the left with a set of steps in it. This wall has no steps in it, but it will have, when it's finished, a fence. There's a pool up behind me here, so there's a pool fence requirements involved, and that will go in right after the wall's built. There's an item called a sleeve-it that's installed on 6-foot centers just inside that wall, and it's basically a tube that's secured in the stone, and if you put a fence post and then concrete around it, or whatever you're going to use, steel, vinyl, or whatever, that sleeve-it is for the post, so that works really well. You don't, the fence people are not really allowed to go down through this geogrid, so damaging the geogrid, of course, you lose some of your strength in the wall there. So when we put the sleeve-its in, they go in, we cut around the sleeve-its so as not to damage the rest of the grid itself, like you might do if you had to go through there with a post hole digger and go down through there. Hard to say what shape your grid would be in when you got done. So the sleeve-its eliminate that issue pretty well. So that's kind of a description on the backfill area, the reinforced area they call it. The wall itself is, it's not really a do-it-yourself project. There's an industry associated with these walls. CMA, Concrete Masonry Association, has guidelines and requirements to be a member of their association if you build these materials. Not every manufacturer is part of that, signatory to that. We try to use only CMA approved products. That way you know the concrete's a proper strength and you follow their guidelines on the construction. They have certification for the walls. I went through many years ago, so you go through a class and you take a test, hopefully pass the test, and then I had to do the first 5 projects we built, I think, were inspected by the supplier that actually supplied the block, and before we received our certification. The blocks, in this case, the Allen block weigh 85 pounds a piece, and that's another reason it's not really a do-it-yourself project, but it's critical on the base course, the first course, to get that level. Failure to get the first course, base course level, it means you have problems from then on. It's really hard to get back to level if you don't get that first one. There are shims you can use to help a little bit, but we spend twice the amount of time setting the base course, maybe more than that per block, getting the base course in properly as we do on the rest of the courses. This, I mentioned, is a cord block. They do have solid blocks that use pins, usually plastic pins that go down from one block through one block and into the course below it. That's a locking mechanism, along with, again, gravity and friction. Those blocks weigh 80+ pounds a piece, so different locking mechanism works just as well. Still geogrid needed when you get above that 4 foot plus or minus height there. We're going up, I mentioned, about 9 feet, which is about 16, 17 courses. All that is the backfill that I described. There's a cap made to go on these blocks to kind of give it a finished look and keep somebody or something from disturbing the fill material in those blocks. You can build, we use a lot of Allen block around here because it's made locally, and economic wise it's really the best deal in our town. You're looking at to have us build for you, it's going to vary, of course, by the size of the project. You know, the bigger the project, as far as looking at it from a square foot basis, we can do it a little bit cheaper, but you're probably not going to get under $30 a square foot. If you use an Allen block, it's 8 by 18, which is 1 square foot. So the 30 would be the low end, and in difficult situations, you might be as high as 45. Difficult meaning access is a problem. Maybe we have to hand jive block away, or we've been on pretty steep hillsides where you can't get a machine to at all, and it's just handwork getting the block down there. Just different logistical problems show themselves in some situations, and of course that affects the overall cost. If there's a lot of excavation to do before you can actually do that wall, that's going to affect the cost. If you have to haul that material off rather than dispose of it right in the area or something, that's going to affect the cost. Utility lines in the ground, are you going to have to work around them, or can you work around them? That's always the issue. We always have our projects marked by Miss Utility to let us know where they're at, and then we have our own locator machine to help confirm that, or find a private line. Private lines aren't marked by Miss Utility. You're on your own there, so we try to locate them ourselves with that machine. You know, time-wise, we probably do somewhere in the neighborhood of 100 square feet a day with a 3 and 4 man crew. About half that when it's talking about the base block again, that takes a lot longer. So we do 50, 60 base block in a day, and once you get past that, somewhere around 100. Real easy access, you can pour it on, then we do more than that. So we're back this bright Tuesday morning at Allen Block segmental wall project that we shot a little bit on last week. This is Tuesday, and we've pretty much completed the project. What was our part of it, that is the retaining wall. A couple things I maybe touched on last week and just see a little more evidence of now. This is the geogrid that I spoke about. It's lateral reinforcement. So it comes out between 2 courses of block. This upper course sits on it, tends to lock it in place. These block again are cored, meaning there's holes down through them. So this wall is, the cores are filled, the holes are filled with stone, limestone, all the way top to bottom, which adds additional friction, additional restraint to the movement of the wall. And one other thing that I mentioned, I think there's a lug on the bottom of this block that sits down in behind the top of the one below it. So weight of the block's 85 pounds between gravity, friction, the geogrid, the battering. Battering is set back. Each course is set back about 1 inch from the one below it. All that adds to the strength of the wall. This was engineered. It was above 6 feet tall, which in our state and area is required. Professional engineer design these walls and sign off on them. The grid is roughly in length 60% of the height of the wall. So this wall was 8 or 8 plus, so we had 5 to 5.5 feet length in the grid. So that goes back under the backfill on top of it. It's compacted and works just like a Chinese handcuff to help restrain these blocks from moving anywhere. There is a column of stone directly behind the wall. It's a minimum of a foot thick, almost top to bottom, and that's drainage stone. It's critical on these walls not to let hydrostatic pressure build up, so any water that runs in or falls on the area behind the wall filters down through that stone and finds its way to the bottom or near the bottom, where there's a perforated pipe running the length of the wall. It's 4 inch and it's holes in it, perforated, and then we vent that to the surface, to the outside, by way of PVC. There's one right there. There's one behind me you can maybe see up, which is the second course right there at that height. You keep it near the bottom, of course, and that prevents any water build up to any significance anyway behind the wall. The caps, they have an offset on the bottom of them, and also they kind of lock in like the regular block do. That offset is, the lug on it underneath there is a little farther back, so that allows the cap to hang over the wall inch or inch and a half, and gives a little more character to the wall rather than that being plumb. We finished this off. It's also part of the project was grading in front of this, and this is seeded, and loose straw on this part. We did some straw blanket where it was actual lawn area, going to be lawn area there on the other side of the wall. So that's all as far as the wall this height where you have to have it inspected. This is usually a requirement that you recover the disturbed area and seed it or plant it, or shrubs, flowers, and mulch or something. You can't just leave it raw dirt, at least not in our county, city. So I'm going to go up on top and point out a couple things from on top of the wall there. So I'm up on top of that alum block wall now. This was designed to support this pool these folks have. Prior to us getting here, they just had a wood timber wall that was rotting, had been in for over 20 years and failing, and it was actually working its way, the failure, the collapse of the soil and all was working its way back to the pool coping. So they became a little concerned with it and just needed to look a lot better than what it did too. So these folks are going to concrete this area where I'm standing between the pool coping, existing pool coping, and the wall that we just finished. So all this area is going to be tinted concrete, and I don't think they're going to stamp it, but we do that if they wish. But I think it's just going to be a tinted concrete. Couple, three things that we touched on maybe from down there. Where we're this far off the ground, of course, you have to have something to protect somebody from stepping or falling off. And for the pool to be compliant, of course, you need a pool compliant fence. So this unit right here is called a sleeve-it. That's it's plastic with some steel support in it. Goes down in the ground almost 2 feet. And this is just the cap here on top. That comes off, and the fence people will put the post in there and concrete around it. And these are they're between 6.5 and 7.5 foot centers, depending on what the fence company wants. So I think we put these in on 7, but all in all, there was 19 of them that went around here, and those will go in while we were doing the backfill. You cut around the top piece of geogrid had to be pieced around that, and this other material, that's filter fabric. It's a geotextile that we put down on top of this stone, and it's used to keep the soil, backfill dirt, from migrating into the drainage area over time, and vice versa, I guess, for that matter, to help keep that area clean. This backfill was done as the wall came up, course by course. We backfilled. Course is 8 inches, so it was really compacted well. Sometimes you can't use soil. At times it needs to be stone back there. If we were going to do pavers, interlocking pavers, there probably wouldn't be dirt back here, because it will, even with the compaction we've done, will settle over the years, will settle a little bit, but the concrete's going to be such that it won't affect the concrete. You'll not know it, but that's why you're seeing dirt here. It's not going to be pavers. So that's also why the backfill doesn't come up to the level of the wall. This will be 5 inches, give or take, of of that tinted concrete. Pretty much all this area that you can see all the way to the house. And then to the other end, there's the retaining wall there on that end. It's gonna butt, the coping will butt right up to there. The fence go right around and tie into their privacy fence. I guess this is going to be privacy fence here also. What they're going to install is not going to be a balustered fence. It's going to be privacy. One thing that Jose is working on here is a handrail for steps. Rule of thumb is if you get more than 2 feet off the ground, then you have to have support on those steps or something for somebody to grab. It's either that or you install a landing on the 4th step or every 4th step to eliminate a handrail. Landing has to be a minimum of 3 foot deep front to back. The fence is pretty much going to follow the edge of the wall here. I mentioned we put in the sleevets for that. There'll be a gate in that fence where it ties right there at the steps for access, and I believe they're going to have one on the backside too. So that's pretty much finishes the project. This Allen block wall, again, I mentioned economics was a little more economical in our area because they're made here than the other block. They're a little pound for pound, everything else being the same. It's a little less money than a natural stone wall. We've done a lot of walls, natural stone. We didn't do this one here for these folks, but similar to that. We have several masons qualified to do that. It's more labor intensive and just time consuming and ends up being a little more expensive. Again, everything else being the same. Poured concrete walls, you can substitute those for these segmental walls. It takes a lot of steel, a lot of support in them, especially if they have any kind of height to them. I don't think they're as economical, as practical, because you have to put something on the outside of those walls to make them look decent. Either that or you're looking at just a concrete wall. So that's your veneering faux rock, or I guess you could use real stone on it, which is time consuming and adds greatly to the cost of the wall. So we don't do many of those, but we have done a few. That's I mentioned, I think, you know, you're in the neighborhood of $35 a square foot for a wall like this. It's definitely it definitely depends upon the size of the project. So a larger project, like, and larger I'm saying 1,000 square feet or more versus maybe a couple hundred square feet. If you look at it strictly from a square foot base, we can do the larger projects less per square foot significantly than what we can a smaller project. I think that's the case in most of the walls that we build. Natural stone, same way. So this was leftover conduit that we had. There's going to be low voltage lights, I believe, on this privacy fence when they have it installed. We ran conduit all around the perimeter here, and they'll be able to tee off of that and put power to their lighting. And I think that pretty well covers it. So I hope that was informative for you, and you enjoyed that offering of ours. So thank you. See you again.